All right, here are the notes for 12-12. There's a lot of little vocabulary and theorems here. First off, we're going to start with a chord, and it is a segment that endpoint is on the circle. It's basically a line that's in the circle. Okay. And so we'll be talking about chords today. They're going to use the word distance in a lot of the problems. And when they talk about a distance between a point and a line, well, that's kind of vague when they just say the word distance, because if that's a point and this is a line, well, is that considered the distance? Is this considered the distance? Is this considered the distance? Is this considered the distance between a point and a line? So, in particular, if they use the word distance, they are talking about the shortest distance and the perpendicular distance. So from here, this point to this line, they are talking about this distance here, 90 degrees. Okay, that's just some vocabulary that they are talking about. All right. Here is the first theorem here, and it involves three components. It involves chords. Again, a chord is just basically a line in a circle there. And a chord has a length to it that could be inches, centimeters, feet. So this is in inches or centimeters or feet. There's going to be central angles, and I'll highlight this in red. So this angle from the center is a center angle, or a central angle. This angle here in red is a central angle. And there's also going to be arcs involved, and I guess I'll use this pink highlighter for the arc. And basically, if you are told that the arcs are the same, oh, by the way, arcs are in degrees, center angles are in degrees, and then chords in yellow here is an actual physical length. So if you have congruent central angles, like if that's 80 degrees and that's 80 degrees, then you have congruent arcs. Then this is 3 inches and this would be 3 inches. So in this picture, if angle O is equal to angle P, then segment or chord BC would be congruent to chord DF. If you have congruent angles, then you have congruent chords. This next one is related to the similar. If you have congruent chords, then you have congruent arcs. So if BC and DF are the same, 5 inches, 5 inches, then the arcs BC, and an arc is denoted with that little eyebrow effect there, is congruent to arc in pink DF. Okay, those are arcs. And if arcs are congruent, so this, if that's 100 degrees and this is 100 degrees, then the central angles are congruent. Angle O is congruent to angle P. So they're all related to each other. If arcs are equal, then the angles are equal. If angles are equal, then the chords are equal. If the chords are equal, then the arcs are equal. It's all just one big loop. Okay. Again, arcs are measured in degrees, angles are measured in degrees, and chords are measured in inches and centimeters and feet. The other main theorem for the day is this one here. Chords that are equidistant. Remember when we explained the word distance, that is 90 degrees, the shortest distance from a point. Chords that are equidistant from the center are congruent. So, if I have this chord AB and this chord CD, and if I notice from point center to this E, 90 degrees, this is a distance. If that distance is the same as O to F, then that means if OE is the same as OF, equidistant, then chord AB is equal to chord CD. And this next one will be that in reverse. If the chords are the same length, 7 inches, 7 inches, if you have congruent chords, then you are equidistant from the center. Then that means OE is the same as OF. Equidistant. Okay? Let's move on to a few more, actually, theorems here. In a circle, a diameter that is perpendicular to the chord bisects the chord and its arc. So, first of all, a diameter goes through the center all the way across. If you notice, this is a normal chord here, CD. If you notice that you are perpendicular, and you are the diameter, then you bisect, means cut in two, the chord CD. So if it's 10, now it's 5 and 5, and its arc. This arc CD here in pink. If this was 100 degrees, now it's 50 degrees and 50 degrees. Okay? So, if AB, the diameter, is perpendicular to CD, then CE chord is equal to DE chord, and CB arc, whoops, I don't know what I was doing there, CB arc, and I'm going to form an arc, is congruent to BD arc. All right, 12-7. In a circle, the diameter that bisects the chord, that is not the diameter, is perpendicular to the chord. So it's pretty much the same as this. If you notice, oh, I'm the diameter, I go through the center, I cut the chord in half, then I must be perpendicular here. So that means AB, the diameter, is perpendicular to this chord CD. It all kind of just flip-flops these theorems. Okay? In a circle, the perpendicular bisector of a chord contains the center. So if you're a perpendicular bisector, you must be going through the center. This line must be going through the center. All right, let's try some of these problems here. Number 1, find the value of x. All right, so you've got this circle here. The dot means you're in the center. This is segment x here. We're going to figure out how far it is here to here. What we will notice there's two chords. There's this chord here and this chord here. This one is 36 inches. This one is 18 plus 18, which is also 36. So if you have congruent chords, 36 and 36 in pink, that means you are the same distance. The pink line to the center would be the same. The pink line to the center is the same distance. Distance means the 90-degree distance. So if it's 16 here on the left, it's 16 here on the right. So x is also 16. Number 2a, find the length of the chord to the nearest unit. Okay, you see this right triangle here? We are going to use a squared plus b squared is equal to c squared to figure out this portion here, y. But we want to figure out the entire chord here in yellow. And on the other side of this is another y. Now why is it split in half? Why can't it be like 5 here and 6 here? It's because I'm 90 degrees from the center. Whenever you're 90 degrees with this radius or this diameter going all the way across, that means you split it in half. Because I'm 90 degrees, I'm splitting this thing perfectly in half. So it's y on the left, y on the right. Okay, you can't say that if it wasn't 90 degrees. If this line went like this and I'm not 90 degrees, you cannot say I got split in half. Okay. All right, so let's just do our Pythagorean theorem and then double it to get the entire chord there. So it would be 4 squared plus y squared is equal to 6.8 squared. I'm going to need a calculator here because that's 16 plus y squared, and 6.8 squared is 46.24 minus the 16, and that would be 30.24. And we'll take the square root of 30.24, and you get y is equal to 5.499. I'm just going to go 5.5. So that means this is 5.5, this is 5.5, and the reason why, again, I know that it's, whoops, I'm not on the screen. The reason why I know it's split perfectly in half, because from the center I form 90 degrees, I split that chord in half. So the entire chord is 5.5 times 2, 11. Okay. one last one. Find the distance of the midpoint of the chord to the midpoint of the minor arc. So what the heck is that saying here? From the midpoint of the chord, this is the midpoint, I put a red dot there, to the midpoint of the minor arc. So this is the arc. So basically, you want to figure out this line right there in red, because this is the arc they're talking about. So what's the distance between the midpoint to that arc? So we need to figure out this red line here. Now, how are we going to figure out that red line? Well, all the way across, these are called radiuses. This here is a radius. This radius is 6.8. So all of these are 6.8. Including here to here is 6.8. So if it's 6.8, and this is the arc, and this top portion is 4, then I can figure out what this bottom portion here is in red. I'm sorry. If all the way up and down the radius is 6.8 and this top portion is 4, all I got to do is go 6.8 the radius minus the 4. You will get 2.8, and that's this bottom portion. This is 2.8. 2.8 inches, 2.8 centimeters, who knows? Okay.